for most dielectrics, the P, the polarization generated, is proportional to the field applied, or to the field in the material. So we just define it with a constant, right? So we say that P is epsilon naught. That's there so that this constant, chi e, can be unitless. Right? And that constant is called the electric susceptibility. And the name is clear. It's how susceptible the material is to being polarized when it has an electric field inside of it. Notice I'm not saying applied to it anymore. Electric field inside of it. If you apply a field, it can be reduced by the polarization, and then the polarization is reduced, et cetera, et cetera. It's really just, that's the polarization you get when there's this much E in it. Once we got to the advanced part, we stopped writing applied and internal and external. Okay, so let's now use that. D is epsilon naught E plus P, therefore it's epsilon naught E plus epsilon naught chi E times E. So now you can see things are starting to simplify, and you get that the displacement field is, we pull out epsilon naught, and then I usually write it, the 1 plus chi E times E. So we have a simple linear relation, or a proportional relationship between the polarization and the electric field. That's the electric susceptibility, so that word kind of makes sense. And then also this, we have a proportional relationship between the displacement field and the electric field. And then we also give this a different name. This is just epsilon. So there's also a simple proportion between the displacement field and E, and that's just the permittivity. Okay? That's why when you see it with a naught, epsilon naught, the permittivity of free space, how much field is permitted to be formed due to a charge, right? So this is the permittivity of the material. How much field does it get due to a charge? And so you can see we now have a few constants we're keeping up with, right? There's how much P, polarization, can form. There's how much D, displacement field, can form. And then there was that dielectric constant. How much is the electric field reduced by K? So I like to always have one equation, I usually memorize it, that has all of them related. Is the dielectric constant, you can see, is this 1 plus chi E, right? If you were to take that away, this would be E, which equals epsilon over epsilon naught. So if you ever want to double check your understanding of them, they all fit together like that. So when we did all this, did displacement help? In this example, you could argue it didn't really help that much. We could have just written Gauss's law with epsilon naught E plus P. But as you get to more and more complicated examples, when there's curls and all this stuff, it's helpful to have other fields to use when things get more complicated. But anyway, that's the nature of how to do dielectric problems in electric fields, at least highly symmetric ones that we can solve with Gauss's law.